Hello, Claude. How are you?
Hello.
It's good to see you. Thank you for being here. How are you?
Thank you for the invitation.
Always welcome. And thank you very much. Well, let's wait for a couple of seconds until everybody's here and the audio connections are okay.
Okay.
So
what I will do, I will start sharing my screen.
Okay. You are allowed to do it right now if you wish.
Do you see my screen now?
Yep. Everything is good.
Now, because I'm going to be switching from two presentations, and I've never done that before, I will test how easy it will be.
Okay, let's do the testing then.
So it means that I have to stop sharing and then start again. Okay. Okay, so I'll be doing that later on.
Okay, good. I think there are some people still connecting, so let's wait a couple of minutes and then we can start. As usual, please be free to just, go as you wish with the presentation. If you want to ask people questions in the middle, that's okay. If you prefer to have a question and answer session afterwards, that's okay too. I think everybody's going to be able to follow you in English and to also do questions in English. But in any case, I'm here to try to translate. And also, I'll be trying this feature about captioning. So I will try to caption while you are speaking in Spanish. So let's see if that works for us today. Okay. So that's on my part. I don't know if you have any instructions or any indication you may want to give us?
No.
Thank you.
So all right. Information is the first part will be what you're seeing right now. And the second part will be a subset of my presentations about the paper that was published in At Your Play Computer a few weeks ago about the teachers or professor not teaching software engineering standards.
Cool. So I guess we're ready to go now. We have public, so I'm going to start officially. Good afternoon, everybody. Thank you for being here. Today, as you know, we have a special guest, which is my friend, colleague, Claude Laporte. He's connecting from Canada. He will tell us more about that in a few minutes. But before that, I would like to welcome also the other people who is here now, even though they are not part of this class. I have shared the link with the other group of students and also some other people interested in being here and listening to Claude. So we have the opportunity to have this conversation to this afternoon, and please be free to make any questions that you have. At the end of the presentation, it could be like in writing in the chat, or it could be like talking in English or in Spanish. So that will be the instructions. Once again, thank you very much, Claudia, for being here. And I'm going to let you introduce yourself.
Thank you, Sandra. Hello, everyone. So this presentation today will be split in two. The first part will be, as you see right now on the screen, about software quality assurance and 29110 standard. And that will last about an hour, maybe 45 minutes or so. And then I will be switching to another presentations about the use of or the teaching of standard by software engineering professors. So to save a little bit on the bandwidth, since now you saw my face, I'm going to stop my video and I'll get the video back on at the end of my presentation. So as you can see, within an hour, we cannot cover everything within SQA. So this is why it is a subset of software quality assurance. So a few words about my university. So my university, called ETS, is an engineering school located in Montreal. We have about 11,000 students in engineering, and about 2,000 or so in software and IT engineering. One characteristic of my school is that students at the undergraduate level, they have to go in industry for 3 semesters, not 3 semesters in a row. Typically, they spend 2-3 semesters in class, then 1 semester in industry, 2 semesters in class, and 1 semester in industry. And they work in industry like an employee, and they're being paid, as you can see, during those 3 semesters. So I've been working in the Department of Defense for a few years. And this is where one of my projects was to develop a master's degree in software engineering. It was the first master's degree in software engineering in Canada. So we are back in the late 1980s. So we are in 1988, 1990. And also I developed the Software Engineering Center. Then I left the military and I worked for a company called Earlycon in those days. Now it's got another name. I think it's called Rheinmetall. And my job was to coordinate the development of software engineering processes, system engineering processes, and project management processes. And I stayed there about 7 years. And then I became consultant of Bombardier Transportation. And I've been lucky to go around the world to do some training with the employee of Bombardier. And also I've been a consultant to the Subway of Montreal for a few projects. And in 2000, I joined ETS as a software engineering professor, where I taught software quality assurance and also software process improvement. And since 2002, I've been delegated by Canada as an expert, a software engineering expert. And since 2005, I am the main editor or lead editor of the 29110 series, and I'm going to talk about that later on. So my presentation, after an overview or an introduction, I'll be presenting an overview of software quality assurance, and I'll be talking about the ISO standard about very small entities. And this is the definition of very small entity. It's an organization. It could be a team, it could be a project, it could be an enterprise, it could be a government organization that has up to 25 people that develop either software or systems. And in the context of 29110, a system is typically composed of hardware and software. So I'm going to cover the 29110 and the benefits, because the main reason why we implement standard, it's because we want to gain benefits. There is no value in implementing standards if we don't get advantages. And we'll conclude with the conclusion. So what is software? So depending on your point of view, very different point of view, very different needs, okay? So from the point of view of a student or a computer science professor, it's debug code that has been done within a project or within a class. And for many software developers, it also means partially tested code. And for an organization that keeps the software for a few weeks or a few months, maybe a few years, then it needs some documentation. And for organization that will keep the software for many, many years, and when I say many years, sometimes it's decades, many decades, like the 747 aircraft has been flying for over 40 years. And I'll give you an example in a few seconds. So for those organizations, they have different needs because they have to maintain the software for 20, 30, or 40 years. Naturally, the developers that developed the software originally have left the organization, they have retired, or they have been promoted, so they're not there anymore. So their knowledge about the software development is documented in the documents that you can see on the screen. When I say a document, it could be an electronic document. It doesn't have to be a paper document. So at the top of my slide, it's more the computer science mindset. And as you go down on my slide, it's more the software engineering mindset. And this is what I will be talking about software engineering. So I was talking to you about the 747. So this is a snapshot of a video that was produced a year or so ago about a 747 that they were disassembling. So you can see here that they had a 3.5-inch disc, a diskette. So diskettes have been around in the 1970s, 1960s or so. And as you can see, they've been around until they retired the 747 about a year ago. So when I was saying that those products can live 30, 40 years, then you can see that the maintenance of the software and the equipment has to also be done for 20, 30, or 40 years. So what are the challenges? So organizations want that, and most of them, they want that. They want everything at the same time, naturally. And my hypothesis and my speech is you have to target this as the first objective. If quality is your first objective, then you increase the probability that you'll be delivering faster, cheaper, with less cost overrun than if you were achieving, let's say, to be on the market first. And I'll explain to you why in a few seconds. So in software development, because we are human, we make errors. So we can assume, and you can assume that for the rest of your career, unless we make a major discovery, you will be making errors. And those errors will be translated into defects in the software. And those defects can produce failure. Could be a minor failure, or it could be major failure. And if you read the press, you can see on a weekly basis that we see catastrophe or major failures of software around the world on a weekly basis. So the job in software quality assurance is to ask ourselves, how do we prevent errors to be injected in the software? Okay, how can we reduce the number of errors that will be injected in the software? Ideally to zero, but we're not perfect yet. And the next stage is, because we know that we're not perfect, we have to find ways to detect those errors as soon as possible in the software development cycle. So this is a graph, and at the bottom you see different phases of software development. Starting, you have the starting of the project, then you have the REQ, meaning the requirements phase, then you have the high-level design, low-level design, the coding phase, unit testing, integration testing, system testing, and the shipping of the software. Now, I'm using a waterfall analogy, but in my slides, but you can transfer this analogy for other types of life cycles. And on the left side, you see the density of defects expressed in number of defects per 1,000 lines of code. KLOC means 1,000 line of code. If you don't like KLOC, you could use function points or other measure, but this slide has been developed using 1,000 lines of code, and the concept is the same, whether you use this or another unit of measurement. So typically, defects are injected at each step of the process. And ideally, once the coding is done, then we don't inject new defects, ideally. And what most of the company do is they wait until they have code to debug the code and to do the unit testing, integration testing, and system testing. So my point is, this is quite ridiculous. Okay. My question to you is, what are the problems with this approach? Let you think about this for a second or so. When I say it's ridiculous, is we know that we are injecting defects from the beginning, but we wait until we have code to remove those defects. And this is ridiculous. So if we were be working smarter, we'll be removing the defects right at the beginning where they were injected. So those are the typical problem with this approach. Is the early defects. What I mean by early is, as an example, a requirements defect has not been detected. So this defect will propagate into the architecture, will propagate into the code, will also propagate into the test cases and maybe test procedures. And eventually, once you have code, maybe during unit testing, maybe during system testing or integration testing, then you will discover that there was a defect in the requirement. And it means that you have to go back and in the requirements, modify the requirements, modify the architecture, modify the code, modify the test procedures, modify the test cases, and rerun the unit tests and the system tests and the integration tests. Now, this is what I mean by early defects. Also, relying only on defects can detect hardly all the defects. It's impossible to write for a complex software thousands, if not hundreds of thousands of test cases that will detect all the defects that have been injected. So as you start correcting those defects, then your development activities could become unstable because you could have a team of, let's say, 15, 20 people. And at a certain stage of the project, they will be starting to do the defect correction, and they will be looking for the source of the defect, and they will be modifying the requirements, modifying the architecture. Other teams will be modifying the tests and the test procedures, and other people will also be trying to correct other defects. So you can end up in chaos if you don't have good configuration management, good control about what is changing, who can change things, and where it could be changed. So if you have chaos, your developers could become frustrated because things that have been corrected last week will reappear as defects. Modified things will be crashed or overwritten. Some files will disappear, and people will be frustrated. And all this means that you are wasting time, you're wasting effort, and the company is wasting profit or investment in future projects. And most probably that software will be delivered late to the customer, and the customer will be quite angry. So my point is, developers and managers have to learn to work smarter, not faster. You will discover later on that slower becomes faster, even though it looks like a paradox. It's better to work a little bit slower, putting in place the correct practices, doing the correct things where they should be done. And this, at the end, you will end up being faster than the other guys that have been cutting corners. So my question to you would be, what is needed to produce quality software within schedule and budget? So what I mean by quality software, I mean all the functionalities, including the quality characteristics that I will be presenting to you in a few minutes, within schedule and budget. So this is quite tricky, okay? Anyone can produce anything within schedule, or anyone can produce anything within budget, but producing quality software with all the functionalities, with all the quality characteristics within schedule and budget, that's very difficult. So the analogy that I'm presenting to you is like a clock mechanism, because it means that some processes or some activities are happening sequentially while others are happening in parallel. So think about this as your software process, having many things happening sequentially and parallel. So I would like to show you quality assurance as a toolbox with many tools, but you select the proper tools, and the tools that you select are adapted for a specific project. And let me give you an example. So you are the developer of a software project, and depending on the type, then you'll be selecting different tools. So let's take the analogy of building something. So if you want to build a little house for the dog, then you will need a certain number of tools. which could be quite different from if you want to build a little house for the garden, which could be different from if you want to build a house, a full house, which could be different if you want to build a small building, let's say a medical building or a dental building, which will be quite different if you want to build a high building. So for all of them, you will be using tools, but you will be using different tools for the different types of software. Okay, so see the software tools that I will be presenting to you as a toolbox, and you will be selecting the proper tool for the proper type of project. So the house of quality is, if you look on the left side, you've got the frameworks, the references, the models and standards, and we'll be talking about standards in a few minutes, the defect category, the quality models, with configuration management, traceability. And as we move to the middle, we have software reviews, we have the policies, the processes and procedure, audits and measures, verification and validation. So verification and validation, although they seem similar, verification, you want to make sure that you're doing the things right, and validation, you want to make sure that you've done the right thing. If you go back on my previous slide where I was showing to you a little house for a dog, probably it was built right, but it was not the right thing for that dog. Okay, maybe it was good for a Chihuahua, but it was not good for this type of dog. So verification is, are we building the things right? And validations is, we're asking ourselves, are we building the right thing? So as we move on the right side, we have the cost of quality, code of ethics, checklists, etc. And for a specific project, you develop a quality assurance plan, which could be a page or two for a small project, or it could be for a large project, like the one I've seen either in the military or for in Bombardier as an example. It could be a 50 or 60 or 70 page quality assurance plan. So again, depending on the type of project, you will be selecting the type of quality assurance plan specific to the project. You don't want to do things that you should not be doing for a specific project. You should be selecting the right tools for the right project. And all this acts as the foundation to have stable and capable processes. And I'll show you what it means in a few minutes. To have happy and motivated and productive employees, and to deliver quality software, and to constantly improve your process. Because if you have those items at the bottom of my slide present, as an example, the measures, and if you have a software process that has been documented, as you do project, you'll find the opportunity to improve your process. Okay, this is what we call by continuous improvement. And we need some basic quality assurance function. It could be a member in a team doing quality assurance on some other team. And for small or large organization, it could be a permanent team, a permanent department, a QA department in a large organization. And all this is funded and approved by management. So management approve the resources to do the projects, approve the resources to do quality assurance, and also during the project reviews, the managers and ask questions about the budget, and about the quality, and about the process. Not just about the calendar, okay, but about the quality and the process, because the objective of the manager should be to also improve and become more and more competitive and provide more and more quality products to its customer. So today we are going to cover those 5 points in my presentation. So the first item will be the cost of quality. Let you read this. So it looks like managers are underestimating the resources it takes. So they are cutting corners, and at the end they discover that they have to rework part of the project. So again, as I said, we should be working smarter, not faster. So what are the typical components of the cost of quality? So if we were perfect, 100% of our budget will be in the cost of execution. So developing the software, developing the plan, like project plan, they could be a quality assurance plan, it could be a risk management plan. And since we know that we'll be making mistakes, then we'll be doing evaluations. So there are costs of evaluation, like reviews, inspection, testings, verification, and audits. And if we are intelligent, we will try to learn from our mistake and put in place prevention measures by improving the training, improving the methodologies, tools, gathering other metrics, and putting in place standards. And unfortunately, because as I said earlier, we have to rework, we have the cost of correction, so we have to redo things, okay? And my question to you will be this, since you have been doing some software development, in your own project, do you have any idea about the percentage of the project effort or project budget that goes into this cost category? Again, if we were perfect, it will be zero, but we know that we're not. So it will be wise to know what's the cost there. So let's see, on this slide, you've got the same cost category. And my question, the question I ask to managers when I am invited as a guest, a speaker, or a consultant, I ask them about those 4 cost categories, and I ask them, please tell me where the percentage of your budget goes in those 4 cost categories. And most of them cannot answer because they don't have, or they hide the 3rd cost category, the cost of correction. They don't want to put that in their project, in the budget. Okay. So if you don't measure, you cannot provide those measures, can you say that you're really managing a software project? If you are hiding, or you're not taking into account that you're wasting a high percentage of your budget and effort in the rework, are you really managing a project? And the next question that I ask is this. I ask them, oh, are you producing quality software? And they always answer me, oh, yes, we have product quality, we have quality people, we have quality product. And I say, can you answer those 3 questions? First question is, what is the defect injection, the density of defects injected in the software? And ideally, at each stage of the process, it is measured either by the number of defects per 1,000 lines of code or per function point or whatever you want. Then the second question is what is the percentage of defects that are detected, ideally at each phase of the process? And then the third question is what are the defects that are delivered to your customer? And what I see here is if you cannot provide these product measures, how do you know if you are really developing quality product, quality software? And I would say that roughly, okay, I would say 80%, maybe 90% of company cannot answer the questions on my slide. And all of them will tell you, oh yes, we're managing very tightly our project and we're providing quality software to our customers, but they cannot answer those questions. So my question to you is, read this and try to figure out the number hidden behind my blue box. So the magic number is 40 to 50%. Now, you may not believe me when I make presentations to people in industry or to my graduate students that are working in industry. They say, no, we don't measure that. But when I ask them to think about it, they say, yeah, I think that number is reasonable. And some people even say, oh, I think it's even higher. In our organization, it's 70%. Some people say, oh, in my organization, I think it's more 80%. So I would say that 40 to 50% could be the average in, let's say, high-tech, well-organized organization, but it's probably much, much, much worse in other type of organization. So the thing is, if you don't change anything, you cannot expect the situation to improve. This percentage of rework will not disappear by itself. There is no miracle in software engineering. It's called software engineering because we are engineering the software. So if you're waiting for miracle, go and work in another field. Okay. Well, let me give you an example of a real company. And I had the opportunity to invite the author of this presentation to Montreal many, many years ago. A company is called Raytheon, as you can see. It's still there. If you look on internet, you'll find this company working in the defense and I think maybe also aerospace domain. And those are the number provided to us in the presentation. So this is the cost of the work that I talked to you before. And at the bottom, you can see the number 1, 2, 3, 4 are the maturity level of the CMM. In those days, they were using the software CMM. Today is the CMMI, but back in the 1990s, they were using the software CMM. So when they started the measurement and improvement initiative back in 1988, they had about 41% of rework. Now again, this is a company, this is a high-tech company with hundreds of engineers developing products. Okay? And as they improve, because remember in my presentation, I also the evaluation and prevention costs. So as they put in place prevention measures like improving the process, doing more reviews and things like that, you can see the budget of those prevention and evaluation increased up to a certain point, and then it decreased. But as you can see here, the overall result is the percentage of rework went from 41 to 18 to 11 to 6 and 5%. So by putting in place the correct software quality, software engineering practices, by measuring, by evaluating, by improving the process, the cost of rework goes down. Now imagine that you're working in a company with 41% of rework, and imagine that your competitor is working with just 18% of rework. So the difference between those two organizations is over 20%. So that means that the competitor can offer a product at a lower cost, or the profit margin will be much higher. That means that that competitor will be able to sell, or to improve the process, to put in place new research, to develop new product and become more and more competitive. So this is the name of the game. If you don't move to the right, you're gonna die. This is Darwin, eh? Survival of the fittest. If you're not brilliant enough to put in place the correct practices, you will disappear. You will go bankrupt. Point. That's it. Now let's move to the policies, process, and procedures. This is not very sexy topic, I know that. But life is a bitch, and unfortunately, you have to do things to make things happen correctly. So at the top of the pyramid, you've got the policies that express why you do things, and typically it could be a one sentence or one paragraph in the quality book of any organization. Then we have the processes. Those are the things that you'll be working with, and that provides the answer to the what, who, and where. What is being done, who does the thing, and where in the process. And at the lower level, you have the procedures. So it answers the question of how and using what. And by what, I mean, let's say the tools and the checklists and things like that. And at the bottom, you have the quality records. Those are the proof of execution, the proof to an external or internal auditor or internal or external customer or internal or external quality assurance team that the processes and the procedures have been executed. So on this slide, you see as you increase the maturity, but by maturity, it doesn't mean only CMM maturity. It means that as you improve, as you can see on the slide, you have more visibility, because at the bottom, you have what is typically found in many organizations, which is you put resources in, and after a certain time, certain number of weeks or months, you get something out. Okay? But as you improve, as you document your process, as you measure your process, as you improve your process, this is what we call maturity improvement. Then it means that you'll be achieving more and more your targets, the schedule target, the budget target, the quality target. So you are, as you are improving the bottom line being meeting the budget, meeting the schedule, and delivering all the functionalities with the quality characteristics. And this is an example of a real company called Siemens. And you see that they have a dashboard using 6 measures. And that's all, by the way, maybe since then, because that was, this is a presentation that I attended, I would say at least 20 years ago, maybe 25 years ago. So maybe since then they have improved. But what my point here is this is the dashboard that they have. So on the left side, you have customer satisfaction, the cycle time, the productivity, the maturity of the process, the quality level, and the technology maturity. The trick is, you have to improve all those 6 measures at the same time, because it's easy to reduce the cycle time or to improve the quality to the detriment of the other measures. But to achieve a progress in the 6 dimensions, this is difficult. Okay? This requires, as I said before, processes and measurements and budgets and people to do the process. So let's move to another part of the model, the quality assurance house, the 25,000 series. The 25,000 series is about quality. So it defines different quality factors. And I'll give you an example in a few seconds about the performance efficiency. And let's have a look at the time behavior. So here you have on the left side the different components of that model. And here you have the more definition. So top level, the quality, the one that we want to measure within the performance efficiency is the time behavior. And here the standard provides you with a definition of the meaning of what is time behavior. And at bottom, it says this is one way to measure the response time of a system, as an example. So the 25,000 series provide you with the definitions of all the quality measures, quality characteristics that I've shown you, and also provides you with examples of how to measure those different dimensions. So going back to the model, one consortium called CISQ, it's located in USA. They have succeeded in automating the measurement of those 4 quality characteristics. In other words, they have developed a software that will look at the software product and will automatically evaluate the performance of those 4 quality characteristics. So in other words, when I write a contract, okay, I will be specifying the performance characteristics of those 4 quality measures, and I will expect my supplier to provide me with the proper quality level that I asked. If they don't meet that threshold, then the answer will be, I will not accept your software and I will not pay you until you provide me with the proof that you have achieved the quality characteristics that I show here. And for your information, those are the members of that consortium. As you can see, there are names that are here that are quite known, okay? Very well-known companies. So this is a very large improvement in software engineering where you can automate the measurement of software quality. It doesn't mean that you don't care about the other measures, but it means that we're moving slowly towards the automation of quality measurement. So let's move to another dimension, the revisions, the reviews, let you read this. And I'll give you an example in a few minutes. But the major point, the point that I want to stress here is by doing reviews of your own products. When I say products in software engineering, the word products are anything that you develop, whether it is a plan, requirements and architecture, code or test or whatever, user manual, this is a software product. So when you do reviews on your software product or software product of your colleagues, you learn from your mistakes and you learn from the mistakes of your colleagues. So if you're bright enough, you will be improving your own performance. So let's have a look at what I mean by software review. So this is the analogy here is that the treatment of water from a river. And at the beginning of the treatment process, you've got a river with many bacteria. And as you filter and measure, you remove, let's say, larger bacteria or larger things in the water. And as you process your water through a better filter or finer filter, you get more bacteria removed. And eventually you get drinkable, safe drinking water with a known quantity of bacteria or whatever you want in the water, but that quantity is acceptable to your government or to your city. So this is the analogy that I want to say to show. Same thing in software engineering. At each step of the process, you remove with a set of filters, you remove the defects, and such that when you deliver your product to your customer, you deliver with a known number of remaining defects, ideally 0, but again, nobody is perfect, but you know the percentage of defects or the number of defects left in minor defects into the product. So there are different types of reviews. And I said you can review your own product. This is why on the left side you have personal reviews. And you could have a desk check. The desk check is you ask a colleague, one colleague to look at one of your work product. And you have more formal review processes like walkthrough and inspection. So this is what I mean at the bottom by formality spectrum. On the one on the right are defined in standards. And let me show you how we do reviews at very high speed, okay? Because normally I present review in company in a one-day presentation where we do a presentation about the type of review and we perform review. So when we develop a product, so we have source, and I will give you an example of what I mean by source document. You have source documents and you have standards and templates, and let's say you develop your software specification, then after you've done your work, you have some software work product. And the example here is one of the input document is a contract with the customer. You have the system specification and you have the software specification template. And once you have done your work, then you end up with the software specification. Now let's move to software review. You have the software product to be reviewed, and you have checklist as input. And what goes out are the sorry, oops, there's a problem with the slide. What you have on this slide is you have on the right side the list of anomalies, the list of defects, the measures, and the corrected product. And at the bottom, you have an example. Software specification is an input. Software specification checklist is also an input, and the output is the list of defects, the list of measures, and the software specification that has been collected. And this is for a personal review or desk check. if you want to do an inspection or more formal review, you have more inputs, okay, and you have a little bit more outputs. But the principle is the same. The level of formality is different. The number of people that participates to the review is a little bit different, and we take more measurements during the process, like the number of defects, the time it took to identify the defects, the time it took to remove the defects. So if you understand what I just said, and you make the relationships with the cost of quality, here we have the cost of evaluation. In other words, the time it took to review the software work product by each reviewer, and also your cost of correction by, remember, the cost of rework, the time it takes to correct all the defects that have been detected. So let's move to a real company. It's called Northrop Grumman. Again, it's a high-tech company, mainly located in USA. So on the bottom, you see the different phases of software development. On the left, you see the number of percentage of defects that have been captured at a certain point in the process. And you will notice that 49% of the defect have been injected, I repeat, injected during the requirements phase or requirements activities. And about 20% of the defects have been injected in the design phases. Okay. But, so it means that 70% of the defects have been injected before one line of code was written. But most organizations will discover these defects only in testing, much later during the process. So do you understand why now companies are wasting 40 to 50% of their budget in rework? Now, if you've been working smarter, like this company, remember the filters that I've shown you for my water treatment analogy? So here you have a set of filter, and as you can see, the filter efficiency, by filter efficiency, I mean the defect removal efficiency. In other words, in the requirements phase, the practices in place were able to identify 96% of defects. I said 96% of the defects. If you move to the preliminary design phase, it's 96.8%. So they have put in place certain number of filters at each step of the process, and they know at each step of the process the percentage of defects that have been injected, that was my previous slide, and the percentage of defects that have been detected. This is the slide that you can see. And if they do the things right, it means that the 96% of the defects that have been detected have also been corrected. So the question is, how do you get that high percentage of defects detection and correction? And this is what it gives you. Right? It gives you the green curve, where you detect at each step of the process the defects and you remove them. So this curve that I borrowed from a book from Ron Radis shows that about 50% at that stage of maturity of that company, their percentage of defect detection is 50%. In other words, they detect 1 out of 2 defects. But the good news is this improves from 50% to higher than 90%. So, but when you start doing reviews, you're not very good. You don't see the defects that are still there. But as you do more and more reviews, the percentage of defects identification increases. But the good news is if you detect the defect early, you remove them early, and you deliver to your customer a product with less defect and also a product with higher quality. And let me give you an example of a company that you've heard called Rolls-Royce. And this company is producing jet engine, as you know. And this is a curve that I got from one of the author of the paper, because I attended this presentation back in 2015. So on the left side, you see the defect injection from different developers. So we have people, the developer A injects only 0.5 defect per 1,000 lines of code, and developer F injects 18 defects per 1,000 lines of code. So there is a very wide variation, as you can see, over a factor of 20 between author A and author F. If we look now at the defect detection, it's similar. By that I mean is you have people that detect 30% of defects and people that detect 94% of defects. The good news is you can improve the reduction by, you can improve that author F, because as you can see, the author F is not very good. The author F injects a lot of defect, and author F also detects less defects. His defect identification percentage is only 30%. But the good news is you can teach by this author to introduce or inject less defect, and you can also teach this author to improve the defect identification. Okay. Again, no miracle, it's just hard work, it's software engineering. Once you have data, you can take wise decision. Once you have data, you can take wise decision. Okay, you can say, based on this data, we will put some money or some effort on developer F to improve the way that he injects defects, to reduce it, and to improve the way that he finds defects. Okay, let's move to the models and standards. There are many standards, and I'll show that in the next slides. So we won't go through all of them. I just want to point to you a few. So this is a portfolio of software and system engineering standards. So we have vocabulary standard, and this is very important because people have sometimes different definitions, different meaning for the same word, even in the same organization. So the objective of this is everyone has a common glossary. Everyone has the same dictionary with the same definition. And we have the body of knowledge, which describes what should a software engineering know or what should a system engineering know. And we have life cycle processes, and I'll give you an example in a few seconds. And naturally, we have the 29110 that I'm going to talk in a few minutes. We have standards that talk about documentation. We have standard, there is a standard about requirements, about architecture. There is a complete family of over 10 standards about software testing. I said 10 standards, yes. There is a standard about software maintenance, about project management, about risk, about measurement, about quality, and about measurement. So there is a documented knowledge about all those topics available to you as a student or as a software engineer. So now let's have a look at the 29110 standard. So in a large organization, a large Japanese organization that manufacture electronic products, this is the pyramid of their suppliers. So at the top, you have that Japanese manufacturer, and then that company has contract with 60 prime suppliers, and there are also 600 lower level suppliers and 6,000 lower level producers. So what happened is this, is one defect was not detected in a product or a component made by a low level producer, and that product costed that company about $200 million to fix. In those days, that's a few years ago, electronic product did not have access to internet. So physically, someone had to open the case of that electronic product and remove the chip that contains the program of that product and insert a new one and close the cabinet. So that it means that technicians had to go all over the world and recall those products and remove the chips and put in place new chips. So this is why the cost was very, very huge. Today, as you know, we have over the internet fixes that are downloaded to your product on a weekly or monthly basis. Even cars, modern cars, have a feature where when the user starts its engine, the computer aboard will contact the computer of the company and find out if there are upgrades, and it will automatically download and install those updates to the car. I was reading an article yesterday, and I can provide to your professor the link to this article, where they say that in high-level cars, the very expensive cars of today, there are about 150 microcomputers and 150 million lines of code. And in the article, they said even for middle-sized car, not as expensive as the top-of-the-line cars, there are about 100 processors and 100 million lines of code. So you can imagine there are many defects left in those 100 million lines of code. And this is why many software recalls are not because of mechanical failure, but because of software failure. So at each level of that pyramid, there are VSEs. And so this is what I want to talk about with you. So here we have a high-level ISO committee with the subcommittee number 7 that is responsible for systems and software engineering standard. And my working group that has been established in 2005, working group 24, is responsible for the development of the 29110 series. And the flags that you see are the flags of the experts that are delegated from the countries or the organization to participate, to attend, and to contribute to the development of documents or review of documents. So what we have developed is a roadmap for software developers, a roadmap of four what we call 4 profiles, 4 guides. So the first one is for what we call the entry profile for startups or for a small project of 6% month or less. We have a basic profile for a team working on one project. We have an intermediate profile for an organization having more than one team working in parallel on more than one project. And also we have the advanced profile. We want to help VSE to sustain and grow. The metaphor with those Russian dolls is let's say the basic profile is a superset of the entry profile, and the basic profile is a subset of the intermediate profile. So once you have put in place a profile or a guide, you just have to add a few practices or a process to go to the next level, to the higher profile. And since you are working in Latin America, you are happy to know that there are the 29110 documents. A few of them have been translated in Spanish. So the part 1 is the overview, and the overview is explaining roughly what I'm telling you today, providing you with the concepts and definitions. But the entry profile and the basic profile guides have been translated in Spanish and are available free to you. Naturally, if you want to use the English version, this is the version that has been originally produced and published on the ISO website a few years ago. Let's have a look at the inside of the basic profile. So all of them are similar. I want to use this one because this is the most popular one. So imagine that you have a customer that has a certain number of functionalities that it wants to put into a product. We call it a statement of work, okay, list of needs. And the owner of that VSC will make a decision if it wants to do this project or not. And if the answer is yes, then the project management process will be triggered and the project planning will be executed. Project planning activity will be executed. And at the end of that project planning activity, the output, the main output, is an approved project plan. So once the project plan is approved, then we execute the plan. And those are the typical steps or typical activity that you know. The first one is the implementation initiation. Is like a kickoff meeting where you want to make sure, or the project manager want to make sure that every member of the team knows what it has to do, know their roles, know the process, and knows the schedule and everything that has to be done for that specific customer. As an example, the customer may want to have an installation manual, may want to have a user manual or not. No, so this is, and that kickoff meeting takes 15 to 20 minutes, then everyone can start working on the project, everyone knows what it has to do. And as we execute the project, we evaluate if we are meeting the budget target, the scheduled target, and if we have any problems developing that software for that customer. If we have problem about developing the software or problem about the calendar, then we have to contact the customer and negotiate an arrangement. And eventually, we end up with a product ready to be delivered to your customer. And we call it software configuration because it includes not only the code, it includes whatever the customer wants. As I said, it could be the user guides, installation guides, and maybe the customer wants also the test cases that have been executed. So whatever the customer wants, it will be delivered. Now, it's not because I've shown you things in sequence that we are imposing the waterfall approach. It is just for illustration purposes. You can use the type of life cycle or development cycle that you want. See those white boxes. If I remove my box, see those white boxes in the two processes as Lego blocks that you can assemble using your preferred life cycle or development cycle. Okay. So for each, at high level, we have, if I go back again, at high level, we have processes in the dark blue boxes. And in those two boxes, you have white boxes. Those are activities. And for each activity, there are a certain number of tasks. So let's have a look at one task. So here you have a task, requirements analysis task. On the left side, you have the roles. So the customer and the analyst are involved in the execution of this task. So this task means you have to validate and obtain approval of the software requirements from the customer. And there is some text that explains in more detail what it is. And for each task, we specify what is the input product that is required to execute this task, and what is the output product that will be the output of the execution of this task. So remember, I told you before, there is verification and there is validation. So if you look, the entry product is a verified requirement specification. In other words, the author of the requirement specification, and maybe with the members of the team, have done the software review of the software specification, and they have identified the deficiencies, ambiguities, omissions, etc. And they have done the product right by removing those defects. And the objective of validation is we want to check with the customer that we are developing the right product. So this is why the output, you can see that there is the status of the requirement specification is not verified, it is validated. So it means that the customer has approved the requirement specification, and there is another work product called validation results, and I'll show you in a second. So again, for each step of the process, how the inputs and outputs are defined. So here we have this document called validation result, and it does what it does, what it says. And we say, typically, this document should include the name of the participant, where it happened, when it happened, the typical duration could be an hour or 2 hours, the checklist that you have used to validate the requirements, the items that have been validated, the items that have not been validated, and the defects that have been identified during the validation. And normally you would include also the customer's signature as well as the signature of the author of the requirement specification. And this is used by the process called software implementation. So it's like, see the guides as providing you like a cookbook. So for those of you who do some cooking, you look into the cookbook, and the cookbook will provide you with the list of inputs, the ingredients, and maybe the tools they will use to do the cooking. And the cookbook will provide you in the recipe the list of tasks. And so the task will say, mix this with that for 20 seconds, and then do this, do that. So this is exactly what is the guide, what the guide is providing you. It's like a cookbook, a recipe that you can adapt to your own domain, to the specific projects or products that you are developing. Now, we are providing to the VSC with documents. So this document, so some VSC might say, oh, or some manager might say, oh, I don't need that thing. Why bother writing that validation result document? Let me give you an example where that could be very useful. Imagine that somewhere down the road, there is a conflict between the developer, the VSC, and the customer. And the customer is not happy. The customer goes to the court, and the customer wants money from you, the developer, because the customer says that you have not developed the right product for that customer. Now, if you have developed this document, and this document has been signed by the customer, you can demonstrate to the judge that Mr. or Mrs. Judge, the judge, this is what the customer has approved. All those requirements, he has approved them, and this is exactly what we have provided to this customer. So if this customer is not happy, then we will be more than happy to provide other functionalities, but at a higher cost. So this can help you save the life of your VSC and save you problems and maybe save you money. So now let's go back. Let's go to 4 different examples, real example of real companies that have implemented 29110. So a startup in Peru started with 4 people. 2 of them were graduate students of the master degree of software engineering of the University of Lima. They used the basic profile in agile mode with 6 sprints. And by the way, they have been certified 29110 certification, like you would receive an ISO 9000 certification. So an external auditor came to the company and audited the process and could verify that that company implemented the 29110 in at least 1 project. So the project was 882 hours and with a percentage of rework of 18%. A small company developing cosmetics with 1 software developer, you're working on a 371-hour project with 12% rework. A startup in Canada, 2 developers, almost a 1,000-hour project, using again the basic profile with 12.6%. And the next one, before I show it to you, remember I told you that a VSC could be a team or a department in a large organization. So this is an example. So we have here in Quebec an organization that provides electricity to the 8 million people of Quebec, and there is an organization that provides this electricity. And within that organization, there is an IT division of 2,000 people, about 2,000 people, supporting about 2,000 applications. So this is a huge organization. But as I said, each organization has small departments, small teams. And this is an example. This was one of my graduate students working in this company as a team leader of that project. So a project of 11 people working with a basic profile. It was a 1,500-hour project, and they achieved 9.6% rework. So if we go back to the curve I showed you a few minutes ago, remember the cost average work. So we have the Peruvian startup with 18%. We have the IT startup with 12.6%. We have the cosmetic company with 12% and the utility provider with 9.6%. So my point here is by using proven practices out of existing standard, you are accelerating your maturity. By accelerating, I mean especially for startups, okay, that starts from basically zero. Okay, they start with an idea, and somewhere after a few weeks or a few months, they will have a product to sell. So instead of repeating the mistakes that have been done by companies before, they're using the documented knowledge of software engineering standard, the lessons learned that have been implemented, so they don't repeat the same mistake. So they are working smarter. They are working smarter. And it is as if they are accelerating the maturity of the organization by learning from the mistakes of others. Okay? This is the point of standards. Sorry. So for system engineering, we have essentially, system engineering in 29110, it means that there is hardware and software components like your computer or your cell phone. And we have provided those systems developers with the exactly the same four guides, same four profiles. And here you recognize what I've shown you a few minutes ago, except that if you look on the right side, we are at the system level. And at the system level, when it's time to develop the hardware or buy hardware components, in the construction phase, this is where the people, the electrical engineer or the mechanical engineer will develop their components. And also the software engineers will develop the software components, such that at the next step, the next activity, the integration and verification, then we are integrating the hardware components and the software components to eventually deliver the product to the customer. Going back to the house of quality, the what's in red is what is already embedded in 29110. So in 29110, the basic profile that I showed you a few minutes ago with the two processes, we wanted to make it simple to be used by VSEs and by students. So we didn't provide with 12 processes, we provided you with 2 processes, and we have embedded quality assurance practices in those 2 processes. So you will not find a quality assurance process, but you will find quality assurance activities or tasks in the 2 processes, or in the 3 or 4 processes of higher profiles like the intermediate and the advanced. Now that we have developed those guides and those standards, we did a survey in 2018 and we asked ourselves, now that we have developed those documents, have we done the right things? Because we think that we've done the product rights, okay, because we have removed the defects, because we had hundreds and hundreds of comments to remove ambiguities and conflicts and to clarify a few things. So we did produce the product right, but we ask ourselves, have we produced the right product? In other words, is it useful to VSEs and to customers? So we did a survey, and this is one of the examples. We asked this, the VSEs, how long after you've implemented 29110 did you notice an improvement to your productivity? And as you can see, the answer at the bottom is after just a few months, the first months, they can see a significant improvement to the productivity. We asked the same thing about quality. Again, after the few months, first 3 months, they can notice improvements in their quality. So we asked them, are you satisfied with the overall implementation of 29110? And the answer was 79% of them said that they were either completely or largely satisfied with the overall results of their implementation. So we have happy VSEs and also we add also happy customers. Maybe I skipped a slide, sorry. Yes, I noted that I skipped a slide. So here we have the happy VSE, 89% are the happy VSEs. And here we have the happy customers, 79% for the happy customers. In other words, both were happies. And we also asked people from academia why they are teaching 29110, and there was also another question about why they were using 29110 for software projects, and you can read what is at the bottom of this slide. So we think that we have provided to VSEs good guides, good standards for them to develop good quality products for their customers. We have customers that said that they were happy with their product delivered by their VSEs. And we have professors from universities that are showing why they're using 29110 in their classes and their courses or projects. So let's move on now to another part. We have now a portfolio of standards and guides within the 29110 series. I will not go through all of them. I will just point to two of them. The Agile Software Development Document, which has been reviewed and approved by Working Group 24 a few weeks ago at our recent meeting. And this document is being sent to ISO for the approval of the countries that are participating to SC7 subcommittee. And at the last meeting, we also reviewed a first draft of a DevOps guide, and we should have an updated version to be reviewed and discussed at our next meeting in November of Working Group 24. We also have developed documents for the space industry. So there are about 6 space agencies around the world that have decided to use the basic profile supplemented with some practices that are specific to the space industry to get their supplier to develop software for the space domain. So if you want to know more, you can go on my website at the university at ATS. The website is available in French, English, and in Spanish. So what are the benefits of 29110? I'll let you read this. And this, I think you agree that if you implement 29110, you should get this, but also you have also those benefits for the company, because the company will implement a standard if it gets benefits. And those are the benefits, typical benefits of a VSE. And I stress to you to look at the point number 6, the reduction of rework, because this is where you will get, I would say, the most benefits. But because if you reduce your rework from, let's say, 40% to 20%, then all that time, all that money, all this effort could be invested to do something else, to improve the process, to improve the product, or to develop new products. If you don't do it and your competitor does it, then again, Darwin will win and you may disappear. So in conclusion, okay, we have developed, we, and when I say we, people before me, okay, even though I've contributed a little bit, the people before me have developed a wide spectrum of software quality assurance practices, And I say proven, by that they have been proven in existing projects. They have been proven that they work if you select the proper practices and you apply the proper practices and you train the people to do the things right, and you provide them with the proper tools and the time to do the proper practices, then it should work. It's like, again, my cooking example. If you are provided with the right ingredients, if you know how to do the tasks, and if we give you the correct times and the tools, you should have at the end a good product. But if we cut the corners by not providing you with the right input at a different stage, and not the right tools, and not enough time, then most probably the product at the end will not be very good. Software quality assurance can help you increase the confidence about the development of quality products within budget and schedule. I underline the word confidence because unfortunately, software process standard cannot give you 100% guarantee of success. There are so many parameters in the process, as I told you just a few seconds ago. But if you do the things right, you increase the level of confidence of delivering things to the customer. The 29110 series was developed specifically for VSCs. And again, I stress it could be a standalone enterprise. It could be a team, a project, or a department in a large organization that develops software or system. And we have provided a 4-stage roadmap for software developers as well as for system developers. So before we complete this presentation, I want to leave you with a few thoughts for you to discuss with your professor and amongst yourself. Sorry. So a few years ago in 2018, the editors of a column in the IEEE software document or magazine, those authors have been running this column for about 10 years. And after that, they said, let's step back and let's see what lessons, what we've learned from those 10 years. And what they've learned is that it looks like organizations are not learning from lessons from the past. It looks like we are not learning. We are jumping from one fad to another. In other words, when there is a new language out, there is a new tool out, we jump to the new tool without mastering the previous tool or the previous methodology or the previous language. We are not learning systematically from our mistakes. And also, if you look at the other engineering disciplines like mechanical engineering or civil engineering, those disciplines have increased the quality of their product. As an example, the reliability of their product. If we take the jet engine as an example, the quality characteristics of jet engines have improved by order of magnitudes since the first jet engines were put into production. They have improved the consumption, they have improved the reliability, they have improved the performance, they have reduced the noise level, they have reduced the pollution level, and other characteristics by order of magnitudes. But to do this, you have to measure. And unfortunately, in software, we have an aversion to measurement. That's very bad, because if you cannot measure, how can you improve? So again, if you don't change anything, we cannot expect the situation to improve by itself. No miracle. And if things happen, it will deteriorate more than it will improve. So what I want to leave you is with another thing, is this. A few questions. Why do a large number of organizations do not use proven practices that have been around since the 1970s? Either they don't use or they ignore them. I say 1970s because, as an example, the software inspection process has been developed and published back in the 73, 75 timeframe by Michael Fagan working at IBM. So he developed the software inspection that we still use today. So my question is, why are many organizations not using those proven practices? Why are so many people not working smarter and not using the proven practices? Why are so many managers and developers not learning from their mistakes? Remember the slides that I showed you before? One of the finding was we're not learning from our mistakes. So if we're not learning from our mistakes, we will just repeat them. And my hypothesis is, I think we have a big ego. When I say we, software developers and software managers have a big ego. So by big ego, I mean, oh, I'm so good, I'm so great, or I'm so senior that I don't need to follow a process. Oh, I'm such a senior developer that I don't need to have a template. Oh, I don't need to have a checklist. Oh, I don't make mistakes, so I don't need to have other people review my work product. And this applies to managers also. Okay. So my suggestion to you, if you are looking for your first job, and even if you have a first job, maybe you can think about those issues. So I'm saying to you, select an organization that has used a documented process to develop their software product. And the process could have been developed from scratch, or it could have been developed using 29110 or CMMI as an example. Select an organization where doing reviews is viewed as essential and not as a waste of effort. I've seen many organizations where they say that reviewing a software work product is wasting time. And I'm saying that is stupid, because when you review the work product, you will discover the defects. Remember the Rolls-Royce company and the Grumman company that have numbers showing where defects are injected and where defects are identified and corrected. It's mainly by doing reviews. Select an organization that already improved its process in tools and training. Okay, select an organization where they can show to you that they have a process. They can show to you that they have used the process on different products. Select an organization that will allow you to learn from the mistakes, okay, from your own mistakes and from the mistakes of other guys. And I will complete my presentation with a marketing pitch about the books that we have produced, myself and my co-author, or I should say my co-author and myself. So on the left side, you see two books in French that have been published back in 2011. And on the right side, you see the English textbook that has been published by IEEE Press and Wiley in 2018. And right now, the book is being translated in Spanish by a team of software engineering professors of Latin America. And the latest news I got a few weeks ago is the translation has been completed, and now they are in the process of doing a review of the translation. So another professor will review translation from another professor, such that they will remove ambiguities and things like that. And also, so it means that the book should be available within the next few weeks or few months at a very low cost, as low as possible. And there is also a translation in Chinese happening, and the book in Chinese should be available next year. Why am I saying that? So it shows that there will be in the next 6 months or so, there will be the same books. So it means that there is a rising interest in software quality assurance. Okay? We wrote it in French first, and then we had contacts at IEEE that said that they were interested in having our book translated in English. And then, as you can see, in Spanish and in Chinese. So this technology, I should say, this knowledge, the house of quality that I've showed you, will be available around the world. So it means that competitors, right? Competitors around the world will also be implementing those software quality assurance practices. So if you're not, then most probably, maybe, okay, your rework percentage of rework will be at a high level, while the one of your competitors will be at a lower level. And at the end, Darwin will win, and you will go bankrupt or you will lose your job. So I'm open for questions. So it's time for questions if you want.
Thank you very much, Claude. As always, very nice to always listen to you, to see your examples and all the reasoning you put behind the theory that sometimes looks distant, but when you see the numbers, you can see that actually the smart thing to do is to do quality assurance. So for the students here, yes, Claude Laporte is the author of the textbook we have been using this semester. So I wanted to give you that surprise because I think it's important that you know, like virtuality allow us to have here at our house the very author of the text. So this is the time when you guys can talk to him, like not only questions, but if you want to do some comments or reflections, you are most welcome to participate. You can open your mic and you can freely talk in English or Spanish as you wish. I could translate and then we can keep just making the conversation happen. So
we have a question from Anderson.
Yes.
Yes, okay. Hello. We are so happy. It is so valuable for us to have you here because it is so important for students to have an expert on the matter, and that is the case. I have a question that it is a little bit tricky, but we as a student, we as software engineering students, we know the importance of software quality. But what can we do for change the mindset of the managers of organizations? Because they don't see it, they don't get the idea. We know it, but we don't manage the organization.
This is an excellent question. This is why, remember the few slides before when I showed you where you should be working, that slide that you see, because sometime, and this is what I've seen, okay, I've been around in industry for many years, and there are people that you can convince by bringing arguments, by bringing data, but unfortunately, like other disciplines, there are people that you will never be able to convince. So this is why I put those questions in front of you, or those suggestions, is you should be looking for organizations that demonstrate or can answer those 5 questions to you before you join an organization. Because if you join an organization that say, oh yes, we care about quality, we do a good quality job, then maybe you discover after a few weeks that was not right. Okay, it's like, you know, talking is easy, doing is more complex. So when you do an interview with a company, ask them those 5 questions, or find the answer to those 5 questions, because don't forget that as an employee, you are investing in yourself, in your career. If you are working in a good company, you'll be learning, you'll be growing, you'll be learning from the other guys, you'll be learning about the domain, and you'll be growing your own knowledge base. But if you're working in a company that can, if you look at those 5 questions, and if you're working in a company that has no written process, or poorly processed, or they don't follow a process, they don't measure themselves, they don't improve, they don't do review, what are you going to learn? How are you going to improve? And once you go for a next job, what will be the delta of your competence between the first job and the second job? So my suggestion is, if you believe into this, then ask those 5 questions, and maybe you can add, remember the 2 questions that I had at the beginning. What is the percentage of rework, and can you provide me with the defect density? If they cannot provide you with this, then it's up to you to decide if you want to invest your time, because you are making an investment in yourself. So if you want to invest your time in this company, that could be correct. That's okay. There is no bad answer. But at least you know before you join this company that there are many deficiencies, and you may be frustrated because they have a sloppy process, people are cutting corners, and you're delivering software with many, many defects, and eventually the customer will call you because he's very mad. If you want to suffer, that's okay. There are different types of people on the earth, and some people like to suffer. Or if you work on adrenaline, if you want to work as a firefighter, okay, because there are people that don't want to follow a process, but they are firefighter where they extinguish emergencies, they extinguish fires. Then if you are a firefighter, don't look for a company that has documented process and can answer the questions on this slide and on the slide that I showed you earlier. That's okay too, because if you are someone that needs a lot of adrenaline to work, maybe this is okay for you, and maybe in a few years you'll say, okay, I had my shot, I did work as a firefighter, now I want to have a more stable and capable environment. Did I answer your question, Anderson?
Yeah, thank you. That was
Okay.
Yep, and I tried to translate the best that I could.
Okay.
So more questions, please.
So oh yes, we have another question from Anderson, yes?
Yes.
Yes, sorry, it is not like a question, it is like a curiosity that I have. How many years and how effort do you invest for developing a new standard? How hard it is? How many people is involved in it?
So very good question. So we started from zero, from scratch 15 years ago, because there were no standards for VSCs. Standards have been developed by experts working in large organizations. So I will show you in the next presentation, the 12207 and things like that. So remember that standards have been around since, let's say, the end of the 70s or so. And people working in working groups were people working in large organizations, large company or large government organizations. They were experts being paid by their organization or by the government to participate to working groups for years and years and years. And back in 2005, I was attending a meeting, it was in 2004, sorry. I was attending an ISO meeting in Australia, and we had a coffee discussion. And during the coffee, people got around and they said, oh, are you using this standard in your organization or in your country? And so people said, oh, yes, a few companies. And we had half a dozen people, and we said, hey, what about you in your country? And they said, yeah, oh, the large company are using the standard, but the small company, they don't. And then we said, gee, so it looks like there is a portfolio of standards, very good standards, developed by large organizations for large organizations. But remember the pyramid that I showed you, the pyramid of the Japanese manufacturer? All over the world, there are pyramids like that, all over the world. So it means that the people at the top, they have standards because they are the ones that have been participating to the working groups. But the people at the middle or at the bottom of the pyramid, they have access only to those big, I would say, big standards. So back in 2005, then we said, let's develop standards for the small organization. And we were criticized for many years because the authors of things, everything is there. So you don't need to reinvent the wheel because the answer is there. We said, yeah, we agree with you. Everything is there for large organizations with consultants or experts or people like myself when I work at Oerlikon that can translate the big standards to develop a process for a small team. But in small organization, there is not that level of expertise. They don't have the time, they don't have the resources to translate this very complex standard into a usable process. So this is why we developed the 29110 series. And it took many years because the first few years, we were starting with a blank page. We had nothing that was similar. We eventually discovered that one country had something, but it was much bigger than our target audience. But eventually it took a few years and many cycles of review. I didn't mention that to you, but we had at least 5 cycles of review for each document. When I say cycles of review, within the working group, we had a few review cycles. Then we launched the document for a formal review cycle from 40 or 50 countries around the world, and we get dozens and sometimes hundreds of comments on the same document. We process those comments, we improve the document, we send the document for another review cycle, we get dozens and dozens of comments, we modify them, we improve the documents, and we send it for another review cycle. And at a certain stage, the number of comments are very minimal or minor, and then this is when they get published. So it took many years to develop the first set of documents, and then the first profile we developed was the basic profile, and we said, oh, that's good, that's great, but there are many organizations that for them it's even too big. So we said, let's develop the entry profile for smart startups and small projects. And then we say, okay, now let's help the people that have been using the basic profile. Remember, basic profile is one project and one team. So some VSE will grow, and then it will have 2 customers and 2 small teams or 2 little projects. So let's help them to do more than one project in parallel with more than one team. And then we had people in systems engineering, because I went to a system engineering conference and I presented the basic profile like I did today over one day. And at the end, I asked them, do you think that something similar would be helpful for a systems engineer? And the answer was yes. And I will not tell you the name of the organization that attended my conference, but there were big names, the names that you can see that are very, very familiar to you, okay, in the aerospace or other domains. So, and when I made a presentation in Paris a few years ago, it was indicated in my workshop that it was a presentations for VSCs. And I had people from very large organizations, in European organization, in the aerospace, in very high technical domain. And I said, I knew the answer, but just for fun, I said, oh, are you in the right conference room? Because I'm talking to VSCs and you're in an organization of thousands and thousands and thousands of people. And they said, yes, we know that we are in the right room because, for big projects, we have big process. When I say big process, a big process. But for small projects, we don't have a process. So small teams of 2-3 engineers or 2-3 engineers with a few technicians, we cannot give them the big process because if we do that, we'll kill the project. Okay, they won't be able to do anything. So we let them go. We'll let them do whatever they do with the knowledge they have. But looking at 29110, they say, oh, it's using exactly the same language as the big standards or the big process. Both from the project manager point of view and from the engineer point of view. So they see, they can relate to this standard, 29110, because they recognize themselves. And they say, now we can apply this standard to small teams, okay, that are working on big projects. So this helped us develop other guides, and the market continued to ask us to develop other guides. So this is why we developed the Agile Guide. And the Agile Guide should be available in about 9 months, published by, when I say available, published by ISO in about 9 months. And we are also people asking us to develop DevOps. So the DevOps guides should be available in about 1 year. So we are now, let's say, we are now visible on the radar map. And let me give you an example of a country, Thailand. So Thailand was part of our working group since the beginning. And now in Thailand, they have at least 10 universities teaching 29110. And they have about 500 companies or 500 VSCs that have been certified to the basic profile. So in Thailand, they say, we want to improve the competitiveness of our VSCs. We want them to do better product, cheaper products. Okay, so we ask them to get certified to the 29110. And once they get it, they get special bonuses, special tax rebates, and they are invited to supply software to larger customers or government organizations. So it is working in different countries, and I will show you later on in my second presentation that there are even universities in Latin America that have been certified to the basic profile, like a company. They were audited exactly like a company, a commercial company, by the same auditors, by the same criteria, and they got the same certificate than the otherwise. So this is, in 3 minutes, the 15-year story of 29110. But back to the question, the first question of Anderson, there are still thousands and thousands of managers that look at that and they say, I don't need this, okay? Because they have what I call a seat of the pants process. They have a process which is somewhere in their head, and they say that because it's in their head, it's good. So now what I do, I just ignore them. I just ignore them. Don't waste time. I don't waste time with those guys. I'm not there to convince them. I show them, like I did today, during a one-day seminar, and it's up to them to make their decision. And I hope when after the day of my one-day webinar, that they have enough facts, enough evidence for them to make a decision. And what I told them is what you've seen in the guide. It's not the Bible, it's a guide. So you can modify the guide, modify the terminology to fit your domain, to fit the type of software that you develop. If you don't like the word analyst and you use another term, then change it. But you keep, for the first, I would say you keep for the first 2-3 projects that you do, you keep the essence of the basic profile, and you do it 2-3 times. And once you've done it 2-3 times, then you are in a better position to start making improvement or changes. Okay. So I'm saying to them, don't throw the recipe, do it at least 2-3 times, and then bring your own judgment to modify a few things. Okay.
Thank you so much.
Welcome. So if there are no more questions, what I would suggest, Sandra, is to switch to the other presentation.
Okay, let's do that.
So I will stop sharing for a few seconds, and I will disappear, and I will reappear with something else.
Also, while Claude is preparing the presentation, if you guys feel like you have questions after this, after today, you can always write them to me, and then I can send them to Claude. I'm sure Claude will be happy to answer any question afterwards.
Yes.
Right, Claude? Yeah.
Yes, I will be more than happy. Oops, sorry. It looks like I've got the wrong one. Sorry for that. I should be there in a few seconds.
Yep, we can see it.
finally, okay. So this is a presentation. This is the first time that I do this presentation. And as I did before with my first presentation, I will be speaking in English with Spanish slides. And Spanish slides are provided to you by Google Translate. So if you see funny things, sorry, but this is life. I speak French and English, but my Spanish is not good. So I rely on my friend from Google to translate that. But eventually, some professor from Latin America offered her time to verify my Spanish. Okay, so let me just move on. Before I start my presentation, I want to give you some context. A few years ago, ATS won an award from ISO because we were competing against 8 or 7 other universities to get that award, and I will show you what was the award in a few seconds. And we were given this award because we were able to demonstrate to the panel, to the judge, that we had integrated software engineering standards into our teaching. We have also people from ETS. We had 3 or 4 professors that were editors or co-editors or chair or secretary of the ISO committee responsible for software engineering standards. And also we have developed publications like you've seen before about the use of standards for education. And that was the award. So it was better than nothing, eh? $19,000 just as a prize to thank us for doing what we did before. Okay, so the background of my presentation. So back in New Delhi, in 2018, there was the SC7 committee responsible for, as you know, about the software and system engineering. And I was on a panel presenting 29110. And at the end, we had a question period. And someone says to ask us a question. And the question was, if software engineering professor who do not teach software engineering standard to software engineers, could they be accused of malpractice? And this was the first time that that question was asked to me. And I had, let's say, a second and a half to think about it. And I said, yes. And I will show you why in a few seconds. And by the end, this is a definition of malpractice. So this, the talk that I'm going to make is coming from this article that was published 2 months ago in Anthropology Computer, and was written with my colleague Mirna from Mexico. And if you want to get the copy of the article, there is a link that you can see at the bottom of my slide, and it will bring you to an ISO website where you can download the PDF of the article. So the objectives of the article was to promote the teaching of software engineering standard as sources of documented knowledge, to promote discussion amongst professors and professors that teach or that use software engineering standards, as well as those that don't use software engineering standards to teach. I want to promote discussions amongst professors and students, and also amongst professors, students, and enterprises. Because this is like a system, an ecosystem. It cannot work by itself. So you have to have this discussion amongst those, I would say, those 3 stakeholders or those 3 major participants. Companies have to show that they need competent software engineers that know software engineering standards and how to use software engineering standards. And they have to pass that message to professors, and then professor can teach those standards to their students. And what was not the objective of the article was I didn't want to trigger a debate about the meaning of malpractice or negligence. I didn't want to trigger a legal debate. That was not the objective. My objective was not to blame the professor that do not teach software engineering students to software engineering students, because sometimes and many times they cannot afford because they are quite expensive. Below $100, you cannot buy a software engineering standard. So it's quite expensive for the professors and students. So I do not blame them. And so, oh, sorry. Also, I don't want to promote software engineering standard as silver bullets. By silver bullets, I mean software engineering standard cannot solve or prevent all problems in software development or maintenance. So there is no miracle, again, there is no miracle, but it can help you provide better software, better quality software within schedule and budget. But there is no miracle, okay, again. So a paradox. So on one side, software engineering standards are sources of codified knowledge. In other words, from successful and failed projects for the last 20 to 30 years, software engineering experts have said, oh, we've learned from this project because they have done this. They failed, fully or partially. Oh, this project succeeded because they've done this practice, they've measured this, they've done this. So this is what I mean by the sources of codified knowledge, knowledge codified and documented in standards. And software engineering standards are not used or ignored by many professors that are mandated. This is what they're paid at the undergraduate level, mainly, okay, to transfer knowledge, transfer proven practices from software engineering standard to students. Okay? Because most of the undergraduate level student, that will be their last degree. They will have a bachelor degree in software engineering student or computer science, and this will be their terminal degree. They will not go for a master's degree or PhD. So this is why we have to provide those software engineering students with all the tools they need for their career. And the consequence of that is many students will end up in organization with a deficit or a lack of essential knowledge or ignoring the advantage and disadvantage of software engineering standards. So my question is this acceptable to students and enterprises? And I think you can know from what I told you before that this is totally unacceptable. Totally unacceptable. Now, let's open a parenthesis. Now you see maybe laws of physics, of chemistry that you've learned many years ago and that you've forgotten and you don't want to remember again. Okay, but I want to prove a point. Okay, let's have a look at one of the law called Ohm's law. Okay, and let's have a look inside that Ohm's law for a few seconds. So what it says is that the current between 2 points is proportional to the voltage between those 2 points, and it is roughly the resistance that will be that factor that for a fixed voltage will modify the current. So that's all there is. Okay, that's all there is. But if you go deeper, then we have that knowledge that we know that the resistance of material it depends on two factors: the material it uses and as well as its shape. And if we go deeper, then we know that the resistance is equal to resistivity rho times L over A. And here you have the definitions where L is the length, A is the area, and rho is the resistivity in ohm meter. And if you go down another level, then we have that resistivity. Let's say we take the resistivity of silver, and it says that at 20 degrees Celsius, it is 1.59 times 10 to the minus 8 at 20 degrees Celsius. And if you go on the right side of that table, it says that for each degree Kelvin, then that resistivity will change by 0.0038. So this is what electrical engineering students are being taught in class. So my question is, would it be conceivable that a professor teaching basic electrical engineering would not teach the Ohm's law? And the answer is no, because this is a foundation of electrical engineering. And all electrical engineers know this law, and they know that they cannot violate this law. This law is always true, again, within our normal world. Okay, if you go in the sun, it's different. And if you go and if you work at 0 Kelvin, it's different. But let's say that we work unusual application of electrical engineering in our day-to-day work. Those laws are valid all the time. And my other point is teaching is not only showing a few slides, but doing a few problems and doing an lab experiment. You have to integrate the knowledge, because just seeing a few slides will not bring the knowledge deep in your brain that this law is fundamental, that you have to obey this law. And if you try to violate this law will win and you will lose. So all electrical engineers, when they build a product, they have access to either computer model or handbook, and they do the computation to make sure that they use the proper material, the proper area, the proper things, such that it will carry the proper amount of current and the equipment will not catch fire. Okay, everyone knows that. Now, back to this. Can you answer this question? And I won't wait anymore, because there is no law of nature that supports software engineering. What supports software engineering are the laws of logic and mathematics. So we have some deficiency within software engineering that other engineering disciplines do not have, because all other engineering disciplines, whether it is mechanical, civil, chemical engineering, they have laws of nature as a foundation, and they can do their computation, their design, their verification, their validation, and if they follow the laws of nature and they've done it right, there will be no problem. Okay? We don't have this in software engineering. The only thing we have are the standards, and standards are very, very far away from laws of nature, but that's the best we have. Knowledge gained from failed and successful projects. So this is a citation from Jim Moore. Jim was a member of the SC7 committee, and I had the pleasure to work with Jim for many, many years. And he was the representative of IEEE to SC7. And this is a citation that I got from him. So he says, standards are important, not because they represent best practices, but because they represent good enough practices. In other words, if you follow those practices, you should get appropriate results. And also it says that normally courts will view the application of standard as important evidence that engineers perform their work with appropriate diligence and responsibility. And if he is accused of negligence or reckless conduct, an engineer can cite the standard used to demonstrate that he has followed the correct codified professional practices. And if an engineer could be accused of negligence, why could the professors teaching future software engineers who ignore or do not teach software engineering standards could not be accused of malpractice? So what are the advantages and disadvantages? Because unfortunately, as I said before, life is a bitch, and there is nothing that is 100% perfect. There is always positive and negative point, but this is all we have. So on the left side, you see now some advantages or benefits of software engineering standards or other standards too, but let's stay within the domain of software engineering standards. So promote innovation, improve efficiency, competitiveness, give you access to wider markets, clarify the rules of the market, improve the quality, improve the process, improve the credibility. If you get the certification of conformity, that can improve the image or credibility of the organization. Here I'm opening a parenthesis. Remember the Peruvian VSE that obtained a certification back in 2014, if my memory is right. I visited this organization when I went to Lima. I had the opportunity to go to Lima for 3-4 times, and I talked with the managers of that organization. I said, so once you got that certificate, what happened? Oh, he said one journalist heard about that, so he wrote a little article in the newspaper of Lima. And I said, so what happened? He said, the article was published, and the next day, the phone started to ring. I said, what do you mean? He said, we have potential customers or people who said, hey, we read that article in the Lima newspaper, and we saw that you are using an ISO standard to develop software, and you have been certified by an independent auditor to confirm that you're using the standard correctly. Can we talk? Can we talk? In other words, can we talk business? Okay, so this is, again, this is the bottom line of standards. Okay, to provide you the developer, you the manager, you the developer, or you the customer, with practices that will eventually give quality products within budget and schedule. That's the bottom line. And if you do it right, you can then improve your process, improve your product, and get more visibility, get more customer, and grow. Otherwise, again, Darwin will win and you will disappear. Okay. And unfortunately, as I said, there are disadvantages. Standards are difficult to understand, and this is why, back to the question from Anderson before, we developed the 29110, because we knew from the survey we did initially in 2005 and 6 that VSEs do not have the knowledge and expertise to understand the standards that were available in those days. This is why we developed the guides that you've seen before. And there is a cost associated with buying the standard, implementing the standard, and certifying to the standard. Okay, but you may not need the certification if you can demonstrate to a customer, okay, that this is my process. You can show to the customer, this is the process we use. And you can walk through the process with the customer and showing this is how we work. You give us your list of needs, and this is where we will be working with you. You will have to approve this, and we will provide you with those meetings and those documents. And at the end, you will get this product. Then the customers see that the process is not something that is between the ears of the developers, but it is written on paper, and that you have developed a few projects for other customers. So his confidence level will get higher. Okay, so he may not ask for a certification. He may say, okay, I will be talking to a few of your customers if you would like to give me a few reference, and I'll get back to you. And if you have a happy customer, then this potential customer can come back and say, hey, I've been talking to 2 or 3 of the customers, your customers, and they were very happy with the way the project was managed. They were very happy with the communications between me and the managers, and they were happy with the quality of the products. So I want to do a project with you. Okay, so this is the bottom line. So I won't go through all of them, but yes, there is a perception that it is bureaucratic, but unfortunately, as I said, life is a bitch. Sometimes you need evidence to go to court. Sometimes you need evidence to demonstrate to the customer that you've done your homework, or to your partners. Okay, so this is why evidence are being gathered or being developed to eventually for a court decision or to talk with the customer. And I must say that I did participate. I hear one and participate to one dispute where the customer was not happy and he was making all sorts of claims. And hopefully, okay, finally, the software organization was able to retrieve the discussions they had through emails to show to the judge that the customer was not right, what the customer was saying was not right. And for another evidence, it was one of my students that developed a new product, and he was brought to court by someone who was developing the same product. And that guy says, oh, my student was copying on him. And my student was able to show to the judge that the documentation, all the steps of the documentation, similar to 29110, has been developed many years before his product was put on the market, and many years before the other guy was put on the market. So the judge rejected what the other guy was saying, and saying, with the evidence I have all the evidence that this software engineering guy went through all the process, and there is a date and there is a signature. So those evidence for me means that this guy has developed the product many years before you start to develop yours. So your case is rejected. So this is why it may not happen in your life, in your career, but it's like an insurance, like a car insurance. You may not need insurance for 10 years or 20 years, but the day that you have an accident, you're very happy that you have an insurance. So it's something like that. Okay. So the cost of the quality, I did go through that, so I won't go again through that, but remember, but my point today is we're talking about standards, that element. A report has been produced. Remember, I talked to you about the CISQ consortium. So they produced 3 years ago a report, and they did produce one also a few months ago. But let's have a look at the 2018 document. So what they say here is most organizations do not collect cost of quality data. So without this information, they cannot answer those two questions. So what is the cost of poor quality in my organization? What I mean by poor quality, if you're not doing things right, then you have to do some rework, and you waste time, and you waste money, and you waste effort. And how investments in our process affect the cost of quality and the cost of ownership. In other words, if you don't have metrics about the cost of quality, why would you invest $10,000 or $20,000 in improving the process, in buying a tool, or improving the methodologies, or improving the training? You don't have any foundation on which you can base your decision. And if you invest the money, you will not be able to find out if you had made improvement, okay? Quantifiable improvement. And the bottom line is this. So just to make sure that the translation is correct, it is trillions of dollars. So thousands of billions of dollars. And it's just the cost of poor quality in USA. Okay, so imagine around the world. So again, if we look at the cost of quality, I like the iceberg model. So the iceberg, by definition, is you have things that are visible, and this is the things that are listed on the left, and just a portion of the cost of poor quality is the consequence of the things that are visible. But again, as I said, life is a bitch, and there are many things that are invisible to many managers and developers. When I say invisible, because they don't want to see, but if they work intelligently and they take measurements and they do their homework correctly, they will find they should have the information on the right side. As an example, the cost of rework. Okay, the cost of rework is invisible because no one wants to talk about it. It's hidden. No project manager wants to put a line in the budget saying, I have 40% cost of rework, because he knows he will be fired by the upper level management that don't want to know about it, okay, or hear about it. And this is the bottom line of the use of standards. So this is a report produced by Standard Councils of Canada a few months ago, and they showed that the use of standard contributes to the improvement of the gross national product by, as you can see on the right side, by from 19 to 28% in different countries. In other words, again, back to the bottom line, why do you use standards? Yes, there is the quality issues, and that's fundamental, but from the business point of view, it's for the bottom line. Can I improve the quality, the productivity, improve the business revenues, improve the profitability by putting in place standards? And you can see here that the gross domestic product, as you know, there is no miracle. It will not improve by itself. It will improve only by hard work. Okay, going back to ISO. So just for your own culture, the word ISO comes from the Greek word isos. Okay, means equal. In other words, one country, one vote. So as an example, if Mexico or Peru or Ecuador is a member of a C7, it has one vote and it has the same value as the vote of USA or France or Germany. Because at the end, when we submit a document and we ask the country to vote, it is as simple as this. The computer in Geneva will add the number of countries that have voted to support or to reject or to abstain. And at the end, based on a simple formula, it will declare that the standard had been approved or rejected. So every country has an equal vote. And for your information, there are over 23,000 standards that has been published by ISO. Okay. But not 23,000 standards in software engineering. I don't want to scare you. So going back to a C7, remember we're working in a subcommittee responsible for software and system engineering standard. And here you can see that the portfolio, there were about 207 standards published as of July of this year. And there are about 36 countries that are participating members and 22 countries that are observing members. The difference is the participating members have the right to vote, and the observing member have the right to make comments, but they don't have the rights to vote. So don't blame me, blame ISO for that. There are those rules. Okay, sorry for that. And here you can see the map. So in blue, the countries that are members of C7, the 36 countries that are members of C7. So as you can see, we cover a lot of countries, and in yellow, the countries that are observing members. And within Working Group 24, there are about 180 people that follow our work, either by participating actively to our working group meetings, or participating through their country by submitting comments to the process. So I said that you can see here the evolution in red of the portfolio of a C7 standard going back to 87. So what is in blue are the new standards added each year to the portfolio. So as you can see from let's say the 1998 approximately area, it started to grow quite fast, right? The slope started to grow. So it means that at a certain point, we had enough evidence from successful project, from failed project, to gather the lessons learned and start documenting them in more and more and more standards. Okay. And this is the slide I showed you before, okay? And I won't go through all of them, but the point again I want to make is there are standards that covers every aspect of software engineering. Every aspect of software engineering. And if we look at one of the standards, as an example, life cycle standard, and by the definition, it means this exactly. Life, over the life of software product, not only the development cycle, but the complete life cycle. And this is the next slide. So from the day someone wants to acquire a new software product to the day that we retire this product for another one. So that document, that standard, the 12207, covers all the processes, the technical and management processes from what we call from cradle to grave. From the day there was an idea that was submitted to a company to the day that this product was retired and substituted and replaced by another product. Okay, so as I said, yes, this covers every dimensions of software project. So for your own education, there are about 21 countries that are teaching 29110s. And naturally, Ecuador is part of that, and other countries of Latin America. I talked to you about my website before, so no need to do that. And I told you before that one country has successfully implemented 29110 in their university. So in Mexico. So I've been to the state of Zacatecas. I've been to Zacatecas a few times, 6 to 10 times so far. Fortunately, for the last 2 years, we had only Zoom meetings. But so the first meeting was with and this is what exactly happened. Okay, I was introduced to the Secretary of Economy of the state of Zacatecas. And I was very lucky in the sense that the Secretary of Economy was an engineer. So he was well aware that implementing standards should improve the competitiveness, the productivity of VSCs and software companies in the state of Zacatecas. So he was willing to fund a center in Zacatecas, it's called CMAT, to coach and help VSCs and universities in implementing 29110. And he was able to provide some funding to reduce the cost of implementing and to reduce the cost of certification. And the bottom line was 10 universities of Zacatecas, of the state of Zacatecas, have received a standard of conformity to 29110. So it means that the students, they do their end of what we call the capstone project. In many universities at the end of the training, at the end of the undergraduate degree, they do a project, a team project over a few weeks or a few months. And in those 10 universities, they do the team project using 29110. So that's all I had to say about this little presentation about not using standard, not teaching standard to future software engineering students. And for your information, you see on the upper right side the logo of the center called CMAT. So this is the center for which works my co-author Mirna Munoz in Mexico, and they're the one that led coached the implementation of 29110 in the state of Zacatecas. So again, I'm open to questions.
Thank you very much, Claude, for your time. We are running out of time, but yes, if there is one or two questions, I guess we can have them now. If not, you can always ask later on. So, any questions at this point? I guess not, Claude.
That's okay. That's okay, because you are already teaching software engineering standards. So for your student, it's not a surprise, but I just wanted to emphasize the point about malpractice and also the advantages and disadvantages of using standards.
Exactly. I think that they will give my students employability, capabilities compared to students of other universities in my country. So I truly believe that, and I have seen that also, like from students from the past. So that's why I insist, even though, as you say, standards are not as sexy as you know, modern tools or fashion tools, but still I believe it's very important. So thank you very much for stressing that for me with my students, and I hope to have you in the future in new presentations. Anytime you have a possibility to be here, you're more than welcome, and thank you very much again.
Thank you, Sandra, for your invitation, and thank you for assisting to my presentation, and talk to you the next time. It could be in a few weeks or in a few months. Bye-bye.
Yeah, I think in November for sure we will be there at the next meeting of the group. Yeah, so just to finish, I would like everybody, if you can, to put your camera on, and if you, Claude, can help me taking out your presentation so we can take a picture of all of us.
Removing the presentation, you mean?
Yes, please, because so we can see everybody here, and you can see faces.
Yes. Is it better like this?
Yes, yes, thank you very much. So I'm gonna count to 3, but I'm gonna do it in Quechua, which is our native language here. It should be like Shuk, Ishkai, Kimsa. And at Kimsa, you can all see your camera and smile. So we can, so people can see that we have fun this afternoon in this presentation. So there we go. If Carolina and Benjamin can open your cameras, I will like you guys to do that. Shuk, Ishkai, Kimsa, smile, please. Thank you very much, everybody. Thank you, Claude, again, and see you next time. And you guys, see you tomorrow for the laugh.
Bye-bye.
Bye-bye. Thank you.
Thank you so much. Bye-bye.
Hasta mañana.
Bye. Thank you.